Just want to talk about the solution to the group work 2. Once you have found all your values, you need to compare them to this chart here. So this gives us time in 1, 2, and 3 seconds. Remember, you were asked for the positions, the velocities, and the accelerations. And all of these are vector quantities, so each one of them needs to have a symbol of positive or negative, giving the direction, and giving the magnitude. So the value giving the magnitude, okay? You can see that the acceleration is constant and is downwards. This is acceleration due to gravity. So our motion is a free fall. Only because the acceleration was constant could we apply the kinematic equations. And these are the kinematic equations up here, okay? V equals V0. Remember, it was plus AT. So the A is replaced by G since the value is 9.8 for that acceleration. Its symbol is G. And because the acceleration is downwards, I'm going to write a negative here. Okay, so V equals V0 minus GT. Now when I substitute for the value of G, I'm just going to put in 9.8, not negative 9.8, because I took that negative for the downward already. Okay, so you either take it into your equations or you substitute it in the value, but don't do it twice. Don't do it both times. Otherwise, you'll get a double negative turning this positive, and that'll go wrong. This was delta x, okay, equals V0t plus 1/2 AT squared. Same thing, the A is replaced by a negative G. Okay, the delta x is change in position. So this is my initial position, x minus x0. So this is your x, which is here a y because it's vertical. Y equals y0 plus y0t plus 1/2 gt squared. Okay. And then similarly for velocity, the equation was v squared minus v0 squared is equal to 2a delta x. V squared, v0 squared, the a replaced by a negative g, and the delta x replaced by y minus y0. Yeah, delta y. Okay, so these were our kinematic equations. You use them to solve to get these numbers. You're going to plot these numbers, okay, and receive all these graphs in Excel. You're going to plot them. So you should have made a position time graph first. Here's my position, here's my time. Okay, this is going to be on the x-axis, this is going to be on the y-axis, and my final is going to go from positive to negative value. So here it is, being thrown upwards, going to its highest point, and then coming down. Okay? What this means is our ground is actually here. So our origin that we've taken is above the ground at the top of the cliff. Okay, that's the meaning of this position time graph. Okay. So we start at 1 second. We have 8 at 1 second. You're at about 8 meters. At 2 seconds, you're at about 6.4. This is making sense. At 3 seconds, you are at -5. Okay, so somewhere there. The velocity at each of these, this is upwards. We have a positive slope. We have an initial velocity at 1 second. We have the velocity of 3.2. So at 1 second, you're at 3.2. Your initial velocity was given in the question. It's probably around 14. I don't remember. Okay, and it starts falling, losing velocity, because remember, it's going upwards and the acceleration is downwards. So it's losing speed. Okay, so it's a negative. By the time it's at 2 seconds, it's -6.6. At 3, it's -16. There you go. And we see that all these points lie on a straight line. That tells us that our acceleration has to be constant and uniform, and it's going to be a negative acceleration. It should work out to be the value of g. Okay, so that's about 9.8 negative, or approximately 10. Okay, so you should have plotted all of these. This is a solution that you should have got.